Hello everyone, this is Infinity Vision and my name is Rehan Nawaz. This is the fourth lecture on ratio. In previous lecture, we began solving problems related to ratio. So we'll be continuing doing that. And whenever you encounter mathematical problem, what do? You begin by reading the question properly. Because once you read the question properly, you would be able to understand the demand of the question. And once you understand the demand of the question, you would be able to extract all the relevant information. The idea of connecting the relevant information to the demand of the problem, that is nothing but the art of problem solving, which we are going to explore further today. So let's get started. So let's see our first problem, that is practice problem 9. The question reads, if x upon q plus r minus p equals y upon r plus p minus q equals z upon p plus q minus r, then show that q minus r into x plus r minus p into y plus p minus q into z equals 0. Now, whenever you see a series of continued ratios which are equal, what do? You begin by equating it with lambda. Now, when you equate x upon q plus r minus p equals y upon r plus p minus q equals z upon p plus q minus r equals to lambda, then you get a freedom that I can write x in terms of lambda, and x is nothing but lambda into q plus r minus p, and what would be y? Y would be nothing but lambda into r plus p minus q, and your z would be nothing but lambda into p plus q minus r. Now, once you have written your x, y, z in terms of lambda and pqr, what you need to do? You just need to substitute these x, y, z in this equation. So let's say I'm just going to see the left hand side of this equation. So in the left hand side, I have q minus r into x. Now x can be replaced by lambda into q plus r minus p, and the second term of the expression is r minus p, and y I'll be writing lambda into r plus p minus q, and the third term is p minus q into z, and z would be nothing but lambda into p plus q minus r. Now, if you notice, you have lambda as common in all the three terms, so you will take lambda as common, and then you will observe the first term. The first term is q minus r into q plus r, q minus r into q plus r. And you know what is a plus b into a minus b? That is a square minus b square. So I can directly write q square minus r square. The second thing I see is minus p being multiplied with q minus r. And the same fashion, the cycle would repeat and it would become r square minus p square, because r minus p into r plus p would be r square minus p square, and then minus q into r minus p. And what about the third term? The third term would be p minus q into p minus q, that would be p square minus q square into minus r into p minus q, and the bracket closes. Now, if you notice, you have got q square here and you got minus q square here. So this two will cancel each other. You got minus r square here and you got plus r square. Again, this will cancel each other out. Then you got minus p square here and plus p square here. So this will cancel each other out. So all the square term has been cancelled. Now you will notice minus p into q minus r, your first guy, then minus q into r minus p, the second guy, and minus r into p minus q, your third guy. So minus can be taken out and I'll write minus lambda, and if I open the bracket, p into q would be pq and p into minus r would be minus pr. In the same fashion, minus has been taken out. It would be written plus QR because Q into R is QR, and Q into minus P would be minus PQ. And the last guy would be minus RP. Minus has been taken out, so it would be plus RP, and then it would be minus RQ. Now let's see what we have here. We have PQ and then minus PQ. These will cancel each other out. I have QR and then minus RQ. So this will also cancel each other out. And then I have RP and minus PR. This will cancel each other out. So you got minus lambda into 0, which is nothing but equal to 0, and which is your right hand side. So this is how we solve this problem. Let's see our next problem, practice problem 10. The question reads, if y upon x minus z equals y plus x upon z equals x upon y, then you have to find the ratios of x is to y is to z. Now you again have a continued ratio, y upon x minus z equals y plus x upon z equals x upon y. So I'm going to write this is nothing but equal to lambda. When I see y upon x minus z equals lambda, y plus x upon z equals lambda, and x by y equals lambda. Now when I see x by y equals to lambda, I can write x is nothing but lambda into y because x by y is equal to lambda. Now if I look into this equation, I can say y plus x is nothing but lambda into z. Now I know x is nothing but lambda y, so I'll write y plus lambda y is equal to lambda z. So what I can say that your z is nothing but y into 1 plus lambda upon lambda. So I have written x in terms of y, I have written z in terms of y. So at the same time, if x is lambda y and z is y into 1 plus lambda upon lambda, so I can say y is nothing but equal to y. And now when I have to find the ratio between x is to y is to z, I can say it would be nothing but equivalent to, because x is lambda y, so I'll write lambda y is to y is to lambda plus 1 by lambda into y. Now you know all the three terms have y, so y can cancel each other out, and I have lambda 1 and lambda plus 1 upon lambda. So if I multiply with the whole term with lambda, it would look something like lambda square is to lambda plus 1. Now the question is, what exactly lambda is? If I am able to find what exactly my lambda is, I would be able to find the ratio of x is to y is to z. Now what will help me to get the value of lambda? So I have used this equation, I have used this equation. What I haven't used this equation. Now if I know y upon x minus z, I know y upon x minus z is equal to lambda, so I can say this is nothing but lambda into x minus z. Now if I try to write x as lambda y, then it would be minus z, right? So I can say y by lambda, if I divide both the side by lambda, it would be nothing but lambda y minus z. So I can say that z is nothing but lambda y minus y by lambda, which is y into lambda minus 1 by lambda. So now you have this equation where you say z is nothing but equal to y into lambda minus 1 by lambda, and you have another equation which says z is nothing but y into 1 plus lambda by lambda. What does these two suggest? These two suggest that lambda minus 1 by lambda has to be equal to 1 plus lambda by lambda. That equation will help me find the value of lambda. So let's try solving that. So what I am going to do, I am going to equate 1 plus lambda by lambda equals to lambda minus 1 by lambda, which is nothing but lambda square minus 1 by lambda. right? So now you got a quadratic equation which says lambda square minus 1 is equal to lambda plus 1, and if you try to solve this, this would be lambda square minus lambda minus 2 equals 0. How do you solve a quadratic equation? You have three methods. One is by splitting the middle term and factorize it. The other is by making it a perfect square, and the best one is directly apply the formula. And when you have ax square plus bx plus c equals 0 as your quadratic equation, what is the formula? X is minus b plus minus under root b square minus 4ac by 2a. So same way I am going to find my lambda. I'll do the calculation here. Lambda is equal to minus b, so minus of minus 1 would be 1 plus minus under root. The b square is again minus 1 ka square, that is 1, minus 4 into 1 into minus 2, that would be 1 plus 8. Divided by 2a, 2a is nothing but 2. So if you notice, this is nothing but 1 plus minus root 9 by 2. And what is root 9? That is nothing but 3. So you can say 1 plus minus 3 by 2, which gives you two answers. One is 2 because 1 plus 3 by 2 is 4 by 2, that is 2. Or the other would be 1 minus 3, that is minus 2 by 2, that is going to be minus 1. Right? So you got two values of lambda. One is lambda equals to 2, the other is lambda is equal to minus 1. So you will have two answers. The first answer would be lambda square equals to 2, so 2 square will become 4. Lambda is 2 and lambda plus 1 would be 3. So this is your first answer. The other answer would be, when you replace lambda with minus 1, it would become 1 because the square of minus 1 is 1. This would become minus 1 and this would become minus 1 plus 1, that is 0. So you will have two answers. The one would be 4 is to 2 is to 3 and the other answer would be 1 is to minus 1 is to 0. Now let's see our next problem, that is practice problem 11. You have y plus z equals pb plus qc equals z plus x upon pc plus qa equals x plus y upon pa plus qb. And you have to show that twice of x plus y plus z upon a plus b plus c equals b plus c into x plus c plus a into y plus a plus b into z upon bc plus ca plus ab, right? So if you look into the left hand side of this equation, and if I look into the numerator, that is twice of x plus y plus z, and you have y plus z, z plus x, x plus y. Okay, so this gives me the hint that if I add all the antecedents together, I'll be able to get my numerator, right? So first thing what I can do, I can say that these are equal ratios, so it would be equal to the sum of antecedents upon the sum of consequents. So I can say this is nothing but twice of x plus y plus z because I have added all the antecedents together. Now if I look at the consequent, you have pb, pc, pa. So p being common with a plus b plus c. And then q also being common with c, a and b. So you can say. So what you can do, you can write this is nothing but twice of x plus y plus z upon p plus q into a plus b plus c. And if I look into the left hand side of this equation, it is somehow similar to that, but you have extra term in the consequent, that is p plus q. So we'll just focus that what part are same so that we know that we have moved in a right direction. Now if I look into the right hand side, in the right hand side you have b plus c into x and c plus a into y plus a plus b into z upon bc plus ca plus ab. So I'll try to rearrange because here I see y plus z. So if I look here y and z and they have c plus a and a plus b, so a being common. So what I can do, I can rewrite it as y plus z into a. What about the second guy, z plus x? So I can write z plus x. So here x and here z and b being common. So I can say this is z plus x into b. And the last guy is x plus y. So I can write x plus y into c. You can see that C is common in X and Y. So I have rewritten the numerator. I have rewritten the numerator like this. And the denominator would be BC plus CA plus AB. This is the equation we have to prove. Now, if I look here, you have y plus z into a, z plus x into b, and x plus y into c. So, what I can do, I can rewrite these all equation is also equivalent to, if I see the first equation, y plus z into a upon pb plus qc into a, because I have multiplied and divided my first ratio by the same quantity. Same way, I can write z plus x into b upon z plus x into b upon pc plus qa into b, which is also equivalent to x plus y into c upon pa plus qb into c. So what I did, I just manipulated these equations by multiplying with a by a, b by b, and c by c. Why did I do that? Because if I add sum of antecedents, I will get somehow the antecedent of my right hand side of the equation which we have to prove. So I'll just do the sum of antecedents here. So I'll just write, this is nothing but y plus z into a plus z plus x into b plus x plus y into c divided by a into pb plus qc plus b into pc plus qa and c into pa plus qb. So what I have been able to do, I have been able to prove that this is equivalent to this. So what I need to work on, I need to work on my denominator. If I am able to write my denominator as something like BC plus CA plus AB into P plus Q, things would be done because P plus Q would come out common. So what I am going to do, I am just going to work on my denominator, which I am writing as D. Denominator of this. This I am denoting it by D. So if I try to factorize, I see P, if I open it up, I see P with AB, I see P with AB, and then I see P with BC here, and then I see P with AC. So I can say the sum of consequents would turn out to be P into AB plus BC plus CA, and with the symmetry you can say Q into AC, Q into AB, and Q into BC. So you have successfully been able to write your denominator as P plus Q into AB plus BC plus CA. Now if you notice what you did, you just found out that this ratio is equivalent to this ratio, which means you can simply write twice of x plus y plus z upon P plus Q into A plus B plus C, which is this ratio, is equivalent to, here what you got as a antecedent, A into y plus z plus B into x plus z plus C into x plus y divided by your D, and your D is nothing but P plus Q into AB plus BC plus CA. Now when you look into these two equations, you would be able to see that P plus Q and p plus q are common, so it can be cancelled out. And what you got, twice of x plus y plus z upon a plus b plus c equals to a into y plus z plus b into x plus z plus c into x plus y divided by ab plus bc plus ca, which is nothing but your this equation which you need to prove. Oof. It was a lot of calculations, lot of things going on, but you have sorted yourself out because what you needed to do, you just needed an eye to see the symmetry. Let's solve our next problem, that is practice problem 12. If x by a equals y by b equals z by c, then you have to show that x cube plus a cube upon x square plus a square plus y cube plus b cube upon y square plus b square plus z cube plus c cube upon z square plus c square, that is your left hand side, is equivalent to x plus y plus z whole cube plus a plus b plus c whole cube divided by x plus y plus z whole square plus a plus b plus c whole square. Now, when you encounter such problem, you see that you have a continued ratio, that is x by a, y by b, z by c. So you can say everything is equivalent to lambda. Now, other thing, if you look into the right hand side, you have x plus y plus z and a plus b plus c. So what I can say that it is also equivalent to the sum of antecedents, that is x plus y plus z divided by sum of consequents, because all the three ratios are equivalent and let's say they all are equal to lambda. Now what I can say that x is equivalent to a lambda, y is equivalent to b lambda, and z is equivalent to c lambda. And using this equation you can say x plus y plus z is equivalent to lambda into a plus b plus c. Now, if I look into the left hand side of the equation, the first term is x cube will be replaced by a lambda, so a lambda whole cube plus a cube upon a lambda whole square plus a square. Now, similarly, the second term would be qualified as b lambda whole cube, because y is nothing but b lambda plus b cube upon b lambda whole square plus b square. And in the same way, your third term would be c lambda whole cube plus c cube upon c lambda whole square plus c square. All the three terms are pretty symmetrical, and you can see that a cube would be common and it would be lambda cube plus 1, and below you will have a square common and this would be lambda square plus 1. Same way, it is going to be b cube into lambda cube plus 1 upon b square into lambda plus 1, and the third term would be c cube into lambda cube plus 1 upon c square lambda square plus 1. Now what you can say that, okay, this is going to be my a square will cancel a cube with a, b square will cancel b cube with b, and c square will cancel c cube with c. And you will notice that lambda cube plus 1 upon lambda square plus 1, lambda cube plus 1 upon lambda square plus 1, and lambda cube plus 1 upon lambda square plus 1. The constants are same, so you are going to say lambda cube plus 1 upon lambda square plus 1 into a plus b plus c. This is nothing but your left hand side. Now what about the right hand side? Let's see. When you look into the right hand side, I can replace my x plus y plus z as lambda into a plus b plus c. So I can write this as lambda into a plus b plus c whole cube plus a plus b plus c whole cube divided by lambda into a plus b plus c whole square, because you have x plus y plus z whole square in the first term, and then the second term of the denominator would be a plus b plus c whole square. Now what you can see that a plus b plus c whole cube is common, so in the numerator you will have a plus b plus c whole cube multiplied with lambda cube plus 1, and in the denominator you will have a plus b plus c whole square into lambda square plus 1, because a plus b plus c whole square is common. And then you can see that a plus b plus c whole square will cancel the cube, and you will be left with a plus b plus c into lambda cube plus 1 upon lambda square plus 1. Now you can see your left hand side is equivalent to your right hand side. So hence we have proved the following statement. Let's solve our next problem, that is practice problem 13. You have if 2y plus 2z minus x upon a equals 2z plus 2x minus y upon b equals 2x plus 2y minus z upon c, then you have to show that x upon 2b plus 2c minus a equals y upon 2c plus 2a minus b equals z upon 2a plus 2b minus c. Now whenever you encounter such ratios which are equivalent, now you need to notice that how it has been built. If you focus, the consequent is twice of b plus twice of c minus a. Now I see a here, I see b here, I see c here. So what will happen if I double this up? I can say this ratio would be equivalent to twice of 2z plus 2x minus y upon twice of b. And same way I need twice of c, so I'll just do the same story. This will also be equivalent to twice of 2x plus 2y minus z upon 2c. And then I need to have minus a, which means I'm just going to multiply this with minus 1. So this would become minus of 2y plus 2z minus x upon minus a. Now you see these three ratios as equal ratios, and you know by the theorem that the sum of antecedent upon sum of consequent would be equivalent to the equal ratios. So what I am going to do, I am going to add the antecedents of these three. So if this is 2 into 2, that is 4z, plus 2 into 2, that is 4x minus 2y. And antecedent of this would be 4x, 2 into 2y, that is 4y minus 2z, and this would be minus 2y minus 2z plus x. And what about the consequent? The consequent is going to be 2b plus 2c minus a. Now you have 4z here, you have minus 2z and minus 2z. So this and this would be evaporated. You have minus 2y plus 4y. Again, this will cancel each other. Now you have 4x plus x. So that makes it 9x upon 2b plus 2c minus a. Now you would notice that all the three ratios are very symmetric in nature, and also what you need to prove is also very symmetric in nature. So by symmetry you can say the second one, if you take the 2c, if you double this up 2c and then you double this up 2a, you will just multiply 2 upon 2, and then minus b, you would be able to guess that this is going to be nothing but 9y upon 2c plus 2a minus b. By simply by symmetry you can say that, or even if you want to check, you can check it, because the calculation would be exactly same which we have done for this. And then the third part would be 9z upon 2a plus 2b minus c. You can do independent calculation as well to verify, but since everything is in symmetry and everything is in cyclical, so you can say that okay, these are going to be your answer. And see, when you see that they all are equivalent and 9 being common, so I can say okay, these three can be cancelled out, which suggests that this is going to be your correct implication. Let's solve our next problem, that is practice problem 14. The question reads, if a square plus b square plus c square multiplied with x square plus y square plus z square equals to ax plus by plus cz whole square, then you have to show that x is to a equals y is to b equals z is to c. Now when I see these things, something inside me asks me to cross multiply. That's a pretty brute force. But if I see the symmetry, I can say, okay, this can be multiplied easily because a square is multiplied with x square, then a square is also multiplied with y square, and then a square is multiplied with z square, very symmetrical. And then I'm going to add b square is going to multiply with x square, b square is going to multiply with y square, and b square is going to multiply with z square. And again, c square is going to be multiplied with x square, c square is going to be multiplied with y square. So, though it looked difficult to multiply, but it was very symmetric. And then this whole thing is equivalent to this whole square, a trinomial whole square. What is x plus y plus z whole square? That is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. In the same fashion, we are going to write ax whole square, which is a square x square. Then we are going to write b square y square. Then we are going to write c square z square. Then we are going to write 2abxy. Then we are going to write 2bcyz. Then we are going to write 2acxz. Now when I look into the left hand side and right hand side, I notice that a square x square, b square y square, and c square z square is also there in the right hand side. So I can simply eliminate them or cancel them. Okay, so I have reduced the story. Now let's focus here. You have ay whole square and then you have bx whole square and then you have 2abxy. So I can club it together. I'm sure you understand why am I clubbing it together. Because ay whole square plus bx whole square minus 2aybx. 2abxy can be written as 2aybx. So I have clubbed them because you know what is x minus y whole square? X square plus y square minus 2xy. So this totally fits in our structure. It can be reduced to ay minus bx whole square. I'm sure you are getting the idea. Now, in the same way, you see a square z square, then you see c square x square, and then you see 2ac xz. So I can write a square z square plus c square x square minus 2az cx, because 2ac xz can be written as minus 2az cx. And the last term would be your b square z square and c square y square minus 2bcyz. So this is going to be minus 2bzcy. Now this is a perfect square, this is a perfect square, this is a perfect square, and this whole thing is equivalent to 0. So I can write this whole story as ay minus bx whole square. And this story, the second story, I can write az minus cx whole square. And the third guy is bz minus cy whole square. I'm sure you are able to connect because a square y square plus b square x square minus 2ay bx simply fits in x minus y whole square identity. Same way, az whole square plus cx whole square minus 2az cx, and then bz whole square plus cy whole square minus twice of bz cy. That simply fits in the identity called a minus b whole square or x minus y whole square. Now this whole thing would be equivalent to 0. Why? Because everything what we see in the right hand side has been transported to the left. So what you got in the right, just 0. Now here, a perfect square plus a perfect square plus a perfect square equals to 0. Now whenever you multiply or find a square of any real number, you always get a positive quantity. So basically positive quantity plus positive quantity plus positive quantity is turning out to be 0. This can only happen when each of them is equivalent to 0. So this helps me with the inference that ay minus bx is equal to 0 and az minus cx is also equal to 0 and bz minus cy is equal to 0. Now if I pick this first equation, I can simply write that ay is equal to bx, which means I can write y by b is equal to x by a. This is my first inference. And if I look here, I can write az is equal to cx, which means z by c is equal to x by a. So I can say, by looking at these two equations, I can say that x is to a would be equal to y is to b would be equal to z is to c, and that is what we had to prove, and hence we have been able to prove this idea. So it was a very simple problem, just you needed was little idea about how symmetry works. Let's see our next problem, that is practice problem 15. So the question reads, if L into my plus nz minus lx equals m into nz plus lx minus my equals to n into lx plus my minus nz, then you have to prove that y plus z minus x upon L equals z plus x minus y upon m equals x plus y minus z. Now when I see this problem, I notice that the equation I got here has no consequent. But what I see that you have L, you have m, you have n. What happens if I divide each guy by LMN? So I just divided everything by LMN. You would notice that L will cancel this L, M would cancel this M, and N would cancel this N. So the new ratio which you got, which is also equivalent, is equal to My plus Nz minus Lx upon Mn. The second ratio you got as Nz plus Lx minus My divided by Ln, which is also equivalent to Lx plus My minus Nz upon Lm. Now, if I focus here, this ratio and this ratio, if I add them together, or I would say the sum of antecedents upon sum of consequents would be equivalent to this. So if I add these two, the sum of antecedents would be My would cancel this minus My, and this minus Lx would cancel this Lx. So you would be left with twice of Nz. You would be left with twice of Nz upon, you will add the consequent Ln and Mn where n is common, and the bracket would be m plus L. M plus L. So this is going to be your first guy. In the same fashion, if you consider these two, so this will also be equivalent to, I'll just add the antecedents and consequents together of this ratio. So minus My would be cancelled with plus My, and minus Nz would be cancelled with plus Nz. You would be getting 2Lx upon, you have ln and lm, so L will be common and we'll get m plus n. And the third guy, if you take care of these two ratios, so minus Lx will cancel Lx and minus Nz will cancel Nz, and you would be getting twice of My upon Mn and Lm, m being common, you will be settled down with L plus N. Now this is the story you got, and what you can see that this N is being cancelled by this L is being cancelled by this, and this M is being cancelled by this. And if you look into these ratios, 2, 2, 2 would be cancelled. So what you got? You got x upon m plus n equivalent to y upon L plus n equals to z upon m plus L. Now what you need to have, if you focus here, you have y plus z minus x, y plus z minus x. So what I'm going to do, I'm going to add the antecedents of these two and subtract the antecedent of this. So what I'm taking care, I'm adding the antecedents and subtracting the antecedent of equal ratio, so the equality won't be changed. So I can write y plus z minus x. So I just added these two antecedents and subtracted the first antecedent. In the same fashion, these two would be added. So you have L, this would become 2L, and then M, and then M. This will become M plus N. And then you have to subtract this, that is going to be minus M minus N. If you notice, this would be cancelled, this would be cancelled, you would be getting y plus z minus x upon 2L. In the same way, if you notice, you have to have z plus x minus y. So this means z plus x minus y. So you will get z plus x minus y as your antecedent. And the consequent, you have to add these to z plus x. So m plus m would become 2m plus L plus n, L plus n minus L plus n. Again, you know that this ln would cancel out this ln. At the same time, the third guy, which is your x plus y minus z, means this antecedent plus this antecedent minus this antecedent, x plus y minus z. So this consequent m plus n and this consequent L plus n, that makes it 2n plus L plus m minus this consequent minus m minus L. So eventually you can say L will cancel L, m will cancel m. So now these three ratios, if you look into the antecedents, these are y plus z minus x, z plus x minus y, and x plus y minus z. So I can say, okay, all these are equivalent, and in that consequent you have 2L, then you have 2m, and then 2n. So 2 will be cancelled, and you would be left with y plus z minus x upon L equals z plus x minus y upon m equals x plus y minus z upon n, which is nothing but the equation which you have to prove.